Under our help, which is on the other screen, we do have some things. The one that most people have is setting precision. So if you're inserting blocks and you want to know about the elevation, you go under settings. Then we have this precision settings. We have one for slopes. We have one for grades and distances. And we also have one for volumes. If you select the volume one, that'll get affected. Inside each one is also tutorials for the software. A lot of them include videos that have that are linked to the description, so you can follow along and see what we've done. So there's tutorials, and then there's also the manuals. Okay, and all of our routines begin with an undo mark, so it may undo a number of AutoCAD commands. Some of our routines do have use the command as if you were typing it from here, and we fill in the blanks. So this one will go to the beginning of our routine as opposed to the Civil 3D, which goes back one command. Under settings, here's where we can set a lot of our defaults. I don't think there's anything under. Oh yeah, there's some things for river tools. Also under general, we have land desktop installed. That goes back a long ways. So this is a toggle for whether you have land desktop or Civil 3D installed or AutoCAD. This one says when we insert blocks, do you use blocks with attributes, which is the old soft S point blocks, or do you use the ACC COGO points? Load on startup, I set this to 2, so it will add the reactors, but they won't fire. This is some defaults for grades in and out for points and what we're going to do there. And I think that's about all the ones that are in here that we need to look at today. Okay, so now we can start our demo. A lot of people are not paying attention. Okay, so we'll keep on going. There's no chats and no questions. Okay, I'm going to start in on this drawing. Model space. And we're going to first go into road and create multiple profiles. So here's all the alignments that are in our project. Here's all the surfaces that are in here. Here are all the profile styles, and here are all the profile view styles. I just pick 2, and there's that. So now we're going to go under pipe tools. So there's a number of things we can do before we export to EPA SWMM or hec ras. I'm going to draw my pipes to my profile based on my alignment. I'm just going to do 1, and we're going to go 15 meters each side of center line, and we're only going to show crossing pipes. And this one is a pipe that crosses. Okay, so there's all of our pipes. I'm going to go also under Pipe X. We're going to rename the manholes. We're going to do the storm network. I'm going to start on manhole 1. And we're not going to put a suffix in. And we're going to have it find all manholes along road 1. And we're going to pick this network. And we're going to go 15 meters each side of center line. And we're going to do it by increasing station. So we're going to change this MH6 to SD1. Okay, and it's just gone along. You could also pick them, and it will renumber them in the order that you pick them. Okay, in XP Swim and PC Swim, there are certain requirements. The big one is in XP Swim, they don't want any brackets or spaces, and PC Swim doesn't want any spaces in the name. So you would go rename structures and pipes. We're going to remove any brackets, and we're going to select all of these structures and pipes that are related to that network. And that just ensure it would just, if there was a space in there, would remove that. Next, we want to associate storm areas. So it doesn't matter if you pick calculate storm areas from here, here, or here. They are all the same. And we go OK. You select the pipe, and you select up to 5 areas. You go Enter. So it highlights the first one. What's the runoff coefficient? You place a block, and the block has the runoff coefficient and the area. Then it highlights this one. We're going to go 0.4 perhaps, and we go there. Okay, so now we want to export to PC Swim. And I only do that because, we're going to select all of those and OK. And we'll call yes. And we'll use a Grimsby rain gauge. And if you're in London, you want to change your C factor to impervious. There's a formula there, so we'll just say sure. And it's created this file. So if we go into EPA Swim, when we go File, Open, here's the file we just created, and there's our pipe network with the 2 areas. Now we can go in here and we can go under properties, and maybe we want to change that one from a 750 to a 900. We'll close that, we'll save that, close that. And then if we go over here, now is that 750, and we go import from PC Swim. We can also do this in SSA. SSA will only allow you to export 1 area or catchment area per thing, but if you import through SSA, the file I just created, it will take in all the areas. No, I didn't want to do that. I lied. That's not what I wanted to do. Cancel. And I'm going to go import from PC Swim, and we pick just 1 pipe on that network. Here's the file we just created, and it tells us that we've swapped it from a 0.75 to a 900. And that now is this pipe property, and it's a 900 millimeter. Okay, another tool that you might want to look at is Pipe Editor, and we're going to select all of those on that run. And here's our 900. We can change, this is a more intuitive way of looking at the pipe network. We can change the pipe size to whatever we want. It will ensure that no pipe lower down on the network is smaller than the previous one. So we can change that one back to a 750 perhaps. We can set them all to the same slope. We can change the inverts. We can work from the top down or from the bottom up. We can make sure that it has a delta across the manholes. We're going to hold the obverts. We can raise and lower the network. And we're going to adjust the end. And I think that's it. This one also shows the structures and every pipe that's connected to each structure. And here's all the pipe data. Okay, so we'll just close that. Sure, we'll save that. Close. And that's now 750 again. We can also send our pipes to Excel. And we say, here's the spreadsheet we want to use. And not that one. Example storm. And we go next, and it will bring in a spreadsheet, your standard CIA spreadsheet. Okay, and here's where we tell it to place everything. We're just going to go load settings, and I have a library of settings, so that tells it what column to put the information in. We can even do user-defined properties for both the pipes and the manholes. And we're going to use the storm sheet, and we're going to start placing the data in row 16, and there's a template row in row 10. We go next, and we select what we want to do, export to Excel. And here's the spreadsheet. It includes the areas that we did previously with a weighted runoff coefficient. You can make your changes in here. Maybe again, we want to change this to a 900. And we'll go import to Civil 3D. And that's now a 900. So that's how we can go back and forth to Excel. Let me just close my Excel spreadsheet. Don't save. A new routine we've got is under pipe X, set pipe slopes. So we're going to select all of these, and we go OK, and it's calculated out what the drop is. So we need 0.5% slope. Options, we want to make sure that we adjust the sumps, and we go OK. We go save, close, and now they're all running at the same slope. Pipes to Excel. Another one that we've done is if you have to do catch basins. If we go place catch basins, we're going to go from our finished ground, could be corridor. We have options for a fixed slope, so maybe we want to go 2%, or a variable slope, and it'll go above the pipe, or a fixed slope to an existing pipe. So we're going to go fixed slope. We're going to go down at 2%. There are some warnings that'll happen. We're going to go to OPSD. We're not going to break the pipes and add a null structure. That's one option if you have to do that. We can change that. We're going to tell it to do a 250 millimeter pipe, and we're going to say this is rectangular and it's a 750 by catch CB, and we go OK. So we can go from here to there, and it's put it in at 2%. Or we can change the rules, and we can go, that's not what I wanted at all, edit, and maybe we want to have it go a variable slope, and we go OK, and we'll go to an intersection, and maybe we want to go connection point on the pipe, and that puts it in at 27%, but it matches the obvert. If we go E and we want to go a fixed slope, go OK, pick a point, pick the pipe, and there's 2% slope, and it'll be above the pipe with a drop structure. Just checking to see if there's any questions. Enter. I've had a question about things going back and forth between Excel and between the spreadsheet and the drawing, and we've had very little problems. The only one we've had so far is if it's a box culvert. And now we've resolved that. But for all the people that are using it, it's been quite a stable and useful tool. Okay. Oh, another question about a catch basin. Can you add an option to have a fixed step below grade at catch basin? Yes, we do. When we do the catch basin routine, we go edit, and we want 2 meter cover at the catch basin. So you can change that depth at any time. So that gives you the depth of cover at the catch basin, and not the catch basin itself, but the pipe. The catch basin, the rim goes to the surface that we've specified right here at this surface. Okay, so we're going to go cancel on that one. And so that's, so now, so we have a pond here, and we need to know the capacity of the pond. So if we go under site and we go stage storage from a surface, we're going to say, here's our surface. We're going to start, that's the bottom. These are statistics from that surface. We're going to go up every meter, and we're going to use the surface boundary, and we're going to go okay. And it does all the calculations for us. And then we generate a table. So that gives us the elevation and the capacity of the pond at each elevation. Now, the flip side to that is we have in here somewhere, I have pond volume by slope. So here's the top of the pond. We're going to say we're selecting the top, and here's the inside of the pond, and our top is 192, and we need 5,000 cubic meters, and we want to go down at 2 to 1. And we're going to generate contours every half meet. So there are our contours. And if we go F2, it tells us that that's at 187.5, and that's the volume. Now, if we do it reverse, we also have the option of stage storage from a contour. And we pick these. I'm going to remove the top because we don't know. And enter. We can also have a pond. So if you have a number of cells, you could use that. And we're going to create a file. You can look at the file. And if we go F2, it comes back and gives you the depth at each, the surface area, the perimeter. This one's 187.5 isn't right. It shouldn't be that much surface area. So I don't know. I'll have to look into that. But it gives us the volume for that pond from a contour plan. So you don't even have to build a surface. Okay, so that's that. Another example is ponding in a parking lot. No, I lied. That wasn't the one I wanted to do. First, I'm going to use this one. So we have ponding on our roads. So there's a couple of catch basins, and here's our profile, and we want to know how much water is going to be stored in there. So under many areas, we're going to go road ponding, and we're going to pick our profile. So we go okay, and we're going to use that surface. We pick our profile, and it saves a file. Sure. And we pick our structure. So here it tells us the catch base, the spill elevation, the catch CB elevation, and the depth. And it generates a contour plan, but it goes outside of our area that we're interested in. So I'm going to go no. And this one gives us a closed contour. So I'm going to say yes to that. and it generates a area, and it gives us the volume of our, no, we don't care about the file. Gives us the volume in that we can expect to have stored. Okay, so that's ponding. So, but now we're going to do it a different way. We're going to do it with a parking lot and a catchment. So under many areas, we're going to go label high low point in a catchment area. And we go okay. We pick that. And this is the catchment it's going to create. So we go okay. And we're going to make it into a feature line. And we can plot the high point, but more we're concerned about is the low point. And you can see here, so we can do multiple. Here's the low point, and so this is where it's going to drain. That's the spill elevation. So now we're going to use that road ponding tool again. And this time we're not going to pick the profile. And we pick our surface. And there's a file to save. And we pick our structure. And then we pick the feature line that we created from our catchment. And there's the spill elevation and the catch basin elevation. And this one here, we can see the contour. This is where the flooding would be. We say yes to keeping that one. And there is our elevation, the volume, and the depth. Okay. So there's catchment. And okay, so here we want to know how much cut and fill are in each elevation band. So we call that volume by slices. And you could have 3 surfaces. The third surface would be a water surface elevation. I'm going to just go for 2, and we're going to compare our original ground to our finished ground. And we're going to go 1 meter increments. It is doing it by grid, and we just go okay. Pick the lower left corner, pick the upper right corner, and where the 2 surfaces meet. Sure. Okay, hang on. If we go, and we can even have it label the difference, elevation difference in each one. And if we go F2, it gives you for each elevation what we wanted, but it also generates a table showing you the elevation between 252 and 253, the cut, the fill, the difference, plus it gives us the a summary. Okay, so that's slice volumes. If we go back to here, so some of the municipalities are requiring GIS data. So if we go to our pipe tools, we're going to go Pipe X Utilities, add object data to pipes, and we can add object data table to manholes. Let's do pipes first, and start ID. I'm just going to do a couple of manholes. And we're going to do it in 2D. And again, you can have a library. So this is going to add object data, manhole data, and we go okay. And what it's done, we can see here on this pipe, is if we go edit object data, we pick that. Here's our object data table, and you can go from there. We can also do this now with pipes. Add object data to pipes. We're going to place it in 2D and load from file. And we go OK. And I'm just going to pick a couple of pipes. Enter. And there's our pipes. And again, we can edit object data. And there's all of that information. We can also export it to a shape file for import into Esri or into SSA. There's some options in SSA. Okay, so there's a number of things on pipes. And so now we're going to start looking at river tools. So what I've done is I've created from polylines that show the survey, I've created so here's my channel center line, and here is for each cross section. I've created cross section views. So under road, river tools, we're going to go draw banks in plan by picking the banks in the cross sections. And we're going to start. So the cross sections are 500 feet apart. This is an Imperial project. So I'm going to go start editing at 0, and I'm going to stop at 3,000. We'll be here forever otherwise. So now it highlights the cross section. So you just pick the left side bank and the right side bank. And then you pick the next one. And we're going to plot it in 3D. We go yes. And there's the banks that we've just created. And to look at them, we're going to go into feature lines, and we're going to select our viewer. Oh, pretty straightforward. We can change that to 10. Okay. And here's our other bank. And now we want to export it to hec ras. So if we go under road and we go river tools to hec from cross sections, and we're going to select the left bank and the right bank. And we can flip this cross sections around. I'm going to say no. And we can even reverse the alignment because hec ras prefers the alignment to go downstream as opposed to upstream in Civil 3D. I'm just going to go no, reach ID 1, and it creates the file. So if we go into, so if you add hec ras exe to your options, one of your file support search path in your options, so here we go edit, geometric data, file, import, GIS format. I'm going to say it's in my folder here, and here's the one we just created, and we tell it finished, and here's our cross sections with our banks superimposed. So so you can look at your banks, you can do your magic in hec ras. I'm going to have to say that I don't know anything about hec ras. So then we go into our drawing where we want it brought back into. And so we're going to go import from hec. And I'm going to do the water surface extents, the center line, the velocity, and 3D sections. Here's the, no, that's not the one I want, river tools. And so this one had 3 water surface extents. They had the 5-year, the 10-year, and the 100-year. So I'm going to just tell it to do the first one. So it draws the water extents, then it draws the center line. Then it puts on the velocities. And now it's going to ask if we want to put object data and label the cross sections. If you're doing work in the TRCA area, you can import the 2D sections and it will add in the, there's a specific block for the TRCA, which is the Toronto Regional Conservation Authority, that shows the 100-year storm and a number of other things in it. Okay, so now there's these cross sections. So I'm going to select all the 3D cross sections that got created, and I've created the surface, and now I just have to add those break lines, add, okay, P for previous, find all those cross sections, enter, and now we have a surface. And so here's the banks that it's brought in, but it's every 500 feet. And we want to have some distance between, we want to have some interpolation between them. So under river tools, I'm going to go stretch that 3D polyline to the surface. And here's the surface we're going to stretch it to. And we're going to pick our bank. And we're going to tell it we want to go every 100 feet. And we want to go 200 to the left and 200 to the right. So what it's going to do is it's going to find the elevation at this even 100-foot spot and find out where on that cross section it would meet the original ground surface. So we're going to go to the left 200, to the right 200. And now it's going to walk along that 3D polyline and create another polyline that will be with 100-foot intervals instead of the 500-foot intervals. Takes a minute. Well, it shouldn't take this long. Oh, there it is. Okay, so what it's done is it's created this polyline. Oh, I went 25 feet instead of 100. No, I did 100. So this is now taking the 500-foot interval and made it a 100-foot interval. So just one way of doing it. We've also got imported our velocities. And if we go SSX, we can see that this is a point. Oh, my command line is up here. This is a point for 100-year velocities. So it's going to find all of those. So I've created a surface a velocity surface, and that has nothing in it, and I'm going to add points. And we go P for previous, finds all those points, and I have elevation banding on my cross sections or on my surface so that you can see where the highest velocities are and where the lowest velocities and where there's no velocity. So there you go. We've reviewed a lot of the river tools, so bringing it from Civil 3D into hec ras and back again with some options once it's back in Civil 3D, and even some options before it goes to hec. We've looked at some piping tools, going to Excel and placing catch basins, pipe editor. We've also looked at some ponding problems, either on a road